So if this is your normal curve, it's approximately normal. The 0 would be in the middle, letter B. Any negatives would be to the left of the 0, then A would be the negative. Any positives would be to the right of the 0, so C would be the positive. Make sense? Okay, that's all they wanted you to do is place it. Just to give it a placing. So you guys are starting to get used to this normal curve. Again, this one did the same thing. It's kind of your normal curve. Your 0 is in the middle. Which letter would be the negative? A. And so therefore pick the negative number, negative 1.54. Okay. To the right, you've got two positives. And we do have two positives. The one closer to the 0 is the 0.77. That's your B. The one further away is the 1.54. That's your C. It's just giving it a placement on where it would fall. Now the next part of it was where you had to actually do what we did on Wednesday. And yes, I realize my last one is wrong. It should be 30,000, right? Instead of 31,000? Did yours say 30,000? Okay, I must have wrote 31,000. So I want you to get used to drawing your curve, putting your mean and your standard deviations out there for now. At least give me the curve with some placement so that you can see. If my x value is 34, I fall to the left of the mean. I can tell approximately what my z-score will be between 0 and -1. So if I use my formula and I subtracted them the wrong way and I got a positive, I would say, whoops, I got to subtract the smaller minus the bigger. Okay? 37,000 is right over here, right before here. So somewhere between the 0 and the 1 should be my score. The 30,000 falls right to the left of that 30,500. So between the -2 and the -3, I should fall. And I wrote the wrong number down. But that also tells you smaller minus larger. I need to have a negative number. Now I know I keep repeating that, and I know it sounds silly, but I can't tell you how many kids. Is it 2-2?
It's either 2-2 or 2-2.
2-2, okay. Thank
So
you.
it's not unusual.
It is unusual. Anything plus or minus 2, unusual. Anything plus or minus 3, very unusual, because you're out in the little tail end of it. It's very noticeable when you look at the chart with all the percentiles in it, with the percentages. That's a very small percent are sitting out there. So we consider the plus or minus 2 unusual, and the plus or minus 3, anything to the left or to the right, those very unusual. To find your percentiles, again, either use the one that I gave you, and find 30,500 in here. And it sits at the -2. So any percents over here, you want to add up. There's their purple chart, their blue, whatever color they did this in, with the ones, it's easy from their chart, or from the chart that I gave you. Just add them up. Remember, percentiles stay to the left of you. Because your percentiles go from 0 to 100. At 37,250, that's at the 1, plus or minus, that's the 1 standard deviation above the mean. So it already went through 50% of your chart, and another 34%. So about 84 percentile. Yes? I didn't put it over anything, I just added your percentiles up from your chart. Say that again? Well, you can't use the formula only because the formula says how many of them were to the left. They didn't tell me how many. So I have to go to my chart, my curve that looks like this, and this says 1, -1, 34%, 34%. 2, -2, I forget what the numbers are. It's in your book, or it's the one that I gave you from the regions.
Is that 2.5?
It's 2.4. 2.5
or
2.6%. Or 2.3, depending on which graph you use. If you use the one from the regions, it's more exact. If you use the one from the book, remember it's rounded. And 2.3 is fine. book is rounded. The one from the Regents is more exact. Just getting this out of placement is a really good thing. The 50% mark, you're better than 50% of the kids. It's the halfway mark. So this is really a good thing for placement, so that you get a feel for where you're going. At here, at the plus or minus 1, you're adding up your 50 plus your 34 more. So it just gives you a good placement to go by.
And you always have to add 15 to your number.
Well, if you're to the right of it, that's the easiest way to go. Rather than add up all those numbers, because they're halfway, they're automatically 50. And then you only have to worry about the one side of it. 48, you had to do the same thing. The numbers were a little bit smaller, a little more manageable probably. You had your X value, you had your mean, and again you had your percentiles for the bottom part of it. They gave you at a -1, at a +2, and a -2. When we revisit this after probability, we'll be able to find your percentiles for any z-score you give us, because we're going to use your tables. And your tables is always the area to the left, which is always the same as a percentile.
What do you think of 100%?
Well, I went the other way. Like if you said this whole thing is 100%, right? So if you're here at the 2, if you just add this up, can't you use the 100 minus that rather than add up these other pieces here? Just to be a little different. You could absolutely go 15 plus 34 plus whatever that is, 19, 15, and add those up. And again, it'll be a little bit more exact if you use the one from the Regents. The one from the book, remember, they're rounding. Plus or minus 1 is 68%, plus or minus 2 is 95%, and plus or minus 3 is 99.7. So they round a little bit more. Okay? Okay. Does that make any sense to you, Sade? Using the formula? We have a little formula. Because we know our plus or minus ones that fall on a chart. The ones that fall in the middle, we use this formula. The reason we like to know negative or positive, because we always take x minus the population mean. If x is smaller than the mean, we end up with a negative standard deviation, to the left. If x is bigger than the mean, we end up with a positive. So it's a good placement to remember.